Humans have always looked to the skies with a mixture of awe and apprehension. The weather, in its capricious nature, has shaped civilizations, dictated harvests, and unleashed both beauty and destruction. For centuries, we have dreamed of controlling this formidable force, of bending the elements to our will. Early attempts at weather modification were often rooted in superstition and ritual. Shamans and priests would perform elaborate ceremonies, hoping to appease the rain gods or ward off destructive storms. These practices, while lacking any scientific basis, underscore humanity's age-old desire to influence the weather. With the advent of the scientific revolution, our understanding of meteorology began to evolve. We started to unravel the complex processes that drive weather patterns, from the formation of clouds to the dynamics of air pressure systems. This newfound knowledge, coupled with technological advancements, paved the way for the first scientific forays into weather modification. One such endeavor, known as Operation Cirrus, would forever alter the landscape of meteorological science. This ambitious project, undertaken in the 1940s, marked the first attempt to manipulate a hurricane, a feat that captured the imagination of the world and ignited a debate about the ethics and implications of controlling the weather. The year was 1947. The world was still reeling from the aftermath of World War II, but amidst the post-war recovery efforts, a groundbreaking experiment was taking shape. This was Operation Cirrus, a joint venture between the U.S. government, General Electric, and the U.S. Army Signal Corps. Operation Cirrus was not born out of a desire to simply tinker with the weather. It was a response to a very real and present danger: hurricanes. These powerful storms, capable of unleashing catastrophic damage, were a recurring threat to coastal communities. The goal of Operation Cirrus was to explore the possibility of weakening hurricanes, potentially saving lives and property. The scientists behind Operation Cirrus believed that by seeding clouds with dry ice, they could potentially disrupt the delicate balance of a hurricane's structure. Their hypothesis was rooted in the then nascent understanding of cloud physics and the role of condensation nuclei in the formation of precipitation. Cloud seeding, the technique at the heart of Operation Cirrus, relies on the principle of introducing artificial condensation nuclei into clouds to promote the formation of ice crystals. These ice crystals, once large enough, fall as precipitation, potentially altering a cloud's structure and behavior. In the case of Operation Cirrus, the chosen seeding agent was dry ice, the solid form of carbon dioxide. When dispersed into a cloud containing supercooled water droplets, water existing in liquid form below freezing point, dry ice causes the droplets to freeze rapidly, creating ice crystals. The scientists hypothesized that by seeding a hurricane's rain bands with dry ice, they could trigger the formation of massive amounts of ice crystals. This, they believed, would disrupt the hurricane's airflow, potentially weakening its intensity. The target of Operation Cirrus was a hurricane codenamed King, a Category 5 storm churning its way across the Atlantic Ocean. On October 13, 1947, a B-17 bomber, specially equipped for cloud seeding, took to the skies, carrying 80 pounds of dry ice pellets. The plane flew into the heart of Hurricane King, releasing its payload of dry ice into the storm's rain bands. The scientists on the ground anxiously awaited the results, hoping to witness a decrease in the hurricane's intensity. What followed, however, was not the outcome they had anticipated. Instead of weakening, Hurricane King took an unexpected turn, veering sharply westward and making landfall near Savannah, Georgia. The storm caused significant damage, and while there were no reported fatalities, the unexpected change in course raised serious concerns. Section 5. The Aftermath. A storm of controversy. The aftermath of Operation Cirrus was a maelstrom of controversy. While the scientists involved maintained that the dry ice seeding had no discernible impact on the hurricane's path, public outcry was swift and fierce. Accusations flew, blaming the scientists for steering the hurricane towards land and causing unnecessary destruction. Lawsuits were filed, seeking compensation for the damages caused by the storm. The experiment, initially hailed as a potential breakthrough in weather control, was now mired in legal battles and ethical debates. The controversy surrounding Operation Cirrus had a chilling effect on future research into weather modification. Public distrust, coupled with the scientific uncertainty surrounding the experiment's true impact, made it difficult to secure funding and support for further studies. Section 6. The Legacy of Operation Cirrus, Seeds of Doubt and Hope. Despite the controversy and the inconclusive results, Operation Cirrus left an indelible mark on the field of meteorology. It ignited a spark, a realization that humans might one day possess the ability to influence something as powerful and unpredictable as the weather. The experiment also highlighted the immense complexity of weather systems. The unexpected turn taken by Hurricane King served as a stark reminder that our understanding of these systems was still in its infancy. We were, it seemed, a long way from wielding any kind of meaningful control over the forces of nature. Yet, amidst the doubt, there remained a glimmer of hope. Operation Cirrus, for all its flaws, had shown that manipulating the weather was not merely the stuff of science fiction. It was a tantalizing possibility, a challenge that future generations of scientists would be compelled to explore. Section 7. Weather Modification Today, From Rainmaking to Hail Suppression. In the decades since Operation Cirrus, research into weather modification has continued, albeit cautiously. While the dream of controlling hurricanes remains elusive, scientists have made progress in other areas such as rainmaking and hail suppression. Cloud seeding, the technique pioneered in Operation Cirrus, is now used in various parts of the world to enhance precipitation, particularly in arid and semi-arid regions facing water scarcity. The effectiveness of cloud seeding remains a subject of debate, with some studies showing promising results, while others remain inconclusive. Hail suppression efforts, primarily aimed at reducing damage to crops, have also seen some success. The use of anti-hail cannons, which fire shock waves into the atmosphere to disrupt hail formation, has been reported to reduce hail damage in certain cases. However, the scientific evidence supporting their effectiveness is still being debated. Section 8. Ethical Considerations, Playing God with the Skies. The prospect of weather control, while holding immense promise, is not without its ethical dilemmas. The ability to manipulate the weather, even on a small scale, raises profound questions about our relationship with nature and the potential consequences of our actions. Who gets to decide when and where weather modification is used? What are the potential environmental impacts of these interventions? Could manipulating the weather in one region inadvertently trigger adverse effects in another? These are just some of the ethical considerations that need to be carefully addressed as we venture further into the realm of weather control. The potential for conflict is also a major concern. If we develop the ability to influence the weather, how do we prevent this technology from being weaponized? The idea of countries or entities waging war by manipulating weather patterns is a chilling thought, one that underscores the need for international cooperation and regulation in the field of weather modification. Section 9. Conclusion: The future of weather control. The dream of controlling the weather, once confined to the realms of mythology and science fiction, is now within the grasp of scientific inquiry. While the journey from Operation Cirrus to the present day has been marked by both progress and setbacks, the quest to understand and influence the weather continues. As we delve deeper into the intricacies of our planet's climate system, armed with increasingly sophisticated technologies and a growing awareness of the ethical implications, the possibilities for weather modification seem both tantalizing and daunting. Whether we will ultimately harness the power to shape the skies to our will remains to be seen. But one thing is certain: the story of weather control, much like the weather itself, is far from over. It is a story still being written, a testament to human ingenuity, our enduring fascination with the natural world, and our relentless pursuit of knowledge, even in the face of uncertainty.